again, Honors Chemistry. Now I'm going to walk us through another stoichiometry example using PV equals nRT. So I'm looking at question number 5. Question number 4, you're going to see Google Slides. Because I have answered, I did this in class, but if you were absent, in the Google Slides that are already attached on the Google Classroom, I show you and walk you through and explain the answer for number 4. All right, so now I'm going to do number 5. It says zinc metal reacts vigorously with chlorine gas to form zinc chloride. Let's write and balance that equation. Zinc metal is Zn vigorously with chlorine gas, Hofbrinkel, which means that should be Cl2. And I get zinc chloride. We should know by now that zinc is Zn2 plus, chloride is Cl minus 1. Crisscross method, I should get ZnCl2. So zinc reacts with chlorine gas to form zinc chloride. And what's nice about this is nice and beautifully balanced. 1 zinc, 2 Cls, 2 Cls, beautiful. What volume of chlorine gas at 25 degrees Celsius and 1 atmosphere? So already the hint that I need to use PV equals nRT equation is required to react completely with 1.13 grams of zinc. So I can do the BCA table if I want and only focus on things that I care about in the BCA table. Okay, so I don't care about zinc chloride, the questions that ask about that. I have 1.13 grams of zinc. Now remember, in the BCA table, I only use moles. So if I divide by the molar mass of zinc, which is 65.38 grams per mole of zinc, I get 0.0173 moles of zinc. 0.0173 moles of zinc. And what's pretty nice here is that this is a 1-to-1 mole ratio. So I should also get and need 0.0173 moles of Cl2. All right, so I don't even have to do the rest of the BCA table. This is how much I need, right? So this is a 1-to-1 mole ratio. If you need me to show the work, 0.0173 moles of zinc times 1 mole of Cl2 over 1 mole of Zn, and I get 0.0173 moles of Cl2. Okay, now the question asks about the volume. PV equals nRT, and I can actually solve for volume. It's nRT over P, and we've used that a lot now, and I would remember that equation or that manipulation because that's going to be the question on your final. I already know that N now is 0.0173. T says 25 degrees Celsius, which if I add 273 to that, that's 298 Kelvin. Remember, adding 273 to degrees Celsius gives me Kelvin. And then my pressure is 1 atmosphere. R is, of course, 0.08206 liters times atmosphere per mole Kelvin. So now all I have to do is plug and chug into this equation. Volume is equal to 0.0173 moles times 0.08206 liters times atmospheres per mole Kelvin. T is 298 Kelvin, and then all over P, which is 1 atmosphere. If I do this calculation correctly, you should get 0.423 liters of Cl2 if you do this calculation correctly. Okay, so again, quick walkthrough. I had to write and balance the chemical equation. Then it gave me the amount of zinc I had. It definitely reacts in a 1-to-1 mole ratio. So if I have 0.0173 moles of zinc, which I calculated over here, grams divided by molar mass is moles, that's how many moles of Cl2 I need. Now the question didn't ask for moles of CO2. The question said what volume at a certain temperature and pressure. Well, if the question asks for a volume and it gives me a temperature and pressure, I must be using PV equals nRT, and that's what I did here. Alrighty, so hopefully this quick video was super helpful in doing stoichiometry and using PV equals nRT.